Unraveling the versatility of scatter plots in matplotlib. In the realm of data visualization, scatter plots emerge as a powerful and intuitive tool for uncovering patterns, relationships, and outliers within datasets. Leveraging the capabilities of matplotlib, a popular Python library for creating visualizations, scatter plots provide a visual representation of individual data points plotted on a two-dimensional plane. Let's delve deeper into the concept of scatter plots and explore their significance across various domains. Understanding scatter plots. At its core, a scatter plot is a graphical representation of data points, each represented by a dot or marker on the plot. The position of each dot is determined by the values of two variables, typically referred to as the x-axis and y-axis variables. By visually inspecting the distribution and arrangement of these dots, analysts can discern patterns, correlations, and trends within the data. Importance of scatter plots. Scatter plots play a crucial role in data analysis and visualization for several reasons. Pattern recognition. They enable analysts to identify patterns and relationships between variables, such as linear or nonlinear correlations. Outlier detection. Scatter plots help in identifying outliers or anomalous data points that deviate significantly from the overall trend. Data exploration. They provide a visual means of exploring the distribution and spread of data, aiding in understanding the underlying structure of the dataset. Model evaluation. In machine learning and deep learning, scatter plots are used to evaluate the performance of models by comparing predicted values against actual values. Applications of scatter plots. Scatter plots find applications across various fields, including data visualization, machine learning, deep learning, and data science. Data visualization. In data visualization, scatter plots are used to visualize relationships between variables, such as the correlation between temperature and humidity in weather data. Machine learning. In machine learning, scatter plots are employed to visualize the distribution of data points and assess the suitability of different algorithms for modeling the data. Deep learning. In deep learning, scatter plots are used for visualizing the performance of neural networks by comparing predicted outputs with ground truth labels. Data science. In data science, scatter plots serve as a diagnostic tool for identifying trends, outliers, and patterns in large datasets, aiding in exploratory data analysis. Introduction to scatter function in matplotlib. In matplotlib, creating scatter plots is straightforward using the scatter function. Users can pass arrays or lists containing the x and y coordinates of the data points to be plotted. Additionally, the function accepts various parameters to customize the appearance of the scatter plot, such as marker style, marker size, and colors. Here is the sample example. Don't worry if you are facing difficulty in understanding this simple example. Anyhow, in the next half of this video we are going to learn how to plot and different functions which helps to plot scatter plots. So let's see this example. Import matplotlib.pyplot is plt. Sample data. X equals 1, 2, 3, 4, 5. Y equals 10, 15, 20, 25, 30. Creating a scatter plot. plt.scatter, x, y, color equals, blue, marker equals, O, S equals 100. Adding labels and title. plt.xlabel, x-axis. plt.elabel, y-axis. plt.title, scatter plot. Displaying the plot. plt.show. When we run this code we will get the following output. You can see each data is plotted individually as a point and each scatter point is made up of x-axis and y-axis. In conclusion, scatter plots serve as indispensable tools for visualizing and understanding data across diverse domains. With matplotlib's scatter function, users can create informative and visually appealing scatter plots to extract insights and drive informed decision-making in data-driven endeavors. Unveiling the magic of matplotlib's scatter function. In the dynamic world of data visualization, matplotlib's scatter function stands as a beacon of versatility and utility. From unraveling intricate patterns in datasets to visualizing complex relationships between variables, scatter plots offer a powerful visual representation that transcends the barriers of complexity. Let's embark on a journey to explore the depths of scatter plots, dissecting its parameters and unveiling its potential through a captivating example. Understanding scatter plots. At its essence, a scatter plot is a graphical depiction of data points plotted on a two-dimensional plane. Each data point is represented by a dot or marker, with its position determined by the values of two variables, typically referred to as the x-axis and y-axis variables. Scatter plots provide a visual means of identifying trends, correlations, and outliers within datasets, enabling analysts to extract meaningful insights for these. Exploring the parameters. This is the syntax that should be followed by everyone to plot the scatter plots. Scatter function in pyplot module is used to plot the scatter plots. This function takes a few parameters which are highly used to customize the plot, such as maker color, marker days color, and so on. Now let's see the complete list of parameters and its explanation for the scatter plot function. X, Y. These parameters represent the x and y coordinates of the data points to be plotted. They can be arrays or lists containing numerical values. S. The size of the markers representing the data points. It can be a scalar or an array of the same length as x and y, allowing for variable marker sizes. C. The color of the markers. It can be a single color string, an array of colors corresponding to each data point, or a sequence of numbers mapped to colors using a color map. Marker. The style of the markers, such as O for circles, caret for triangles, or S for squares. Alpha. The transparency of the markers, ranging from 0, fully transparent, to 1, fully opaque. C-map. The color map used to map numerical values to colors when specifying the C parameter. Edge colors. The color of the marker edges. Line widths. The width of the marker edges. Now we know what is a scatter plot and which function is used to plot the scatter plots and what are all the parameters that the scatter plot function will take. Now with this knowledge, let's see an example. Imagine we have a dataset containing the heights and weights of individuals, and we want to create a scatter plot to visualize the relationship between these two variables. Let's use matplotlib scatter function to craft a stunning visualization. Import matplotlib.pyplot as plt. Sample data, heights and weights. Heights equals 160, 165, 170, 175, 180. Weights equals 60, 65, 70, 75, 80. Creating a scatter plot. plt.scatter, heights, weights, S equals 100, C equals blue, marker equals O, alpha equals 0. 7. Adding labels and title. plt.xlabel, height, cm. plt.elabel, weight, kilogram. plt.title, relationship between height and weight. Displaying the plot. plt.show. In this mesmerizing example, we plot the heights on the x-axis and weights on the y-axis, with markers representing each individual. We customize the marker size, color, style, and transparency to create a visually appealing and informative scatter plot that vividly illustrates the relationship between height and weight. In conclusion, matplotlib's scatter function empowers data analysts and visualization enthusiasts alike to craft immersive and insightful scatter plots that transcend the boundaries of data complexity. With its rich array of parameters and intuitive interface, scatter plots serve as invaluable tools for exploring, analyzing, and communicating data-driven insights